So first of all, thank you everyone for joining. So it's our second meetup. We will be focusing on topics related to AWS IoT, and everyone is encouraged to share their use cases, learning experiences, mistakes, as well as success stories. A few housekeeping items, as in, please mute yourself if you are not speaking, and let speaker or organizer know in the chat room that if they are not audible for some reason. Okay. We have a Slack channel as well as Meetup group. If you have not yet joined the Slack channel, please join here, and we'll be having monthly meetups. So there are lined up scheduled meetups in our Meetup group already. This has been volunteered by Tony, who is also, he's working in DigIO as a senior DevOps and cloud engineer. Aditi, she is working with AWS. Hein, he is maintainer for two of FreeRTOS libraries for AWS. And myself, Vishnu Patekar, I'm the CEO of Delighteck. So for today's agenda, we'll go through the customer story. Patric Eckel will share about VinIOT project, how they have used it in Vineyard. After that, we'll just go through OPC-UA and how to use it with green grass and how to use AWS IoT Sitewise. After that, we'll just have a quick online discussion. We can switch your camera on. We can just informally discuss. This will not be recorded. So let me hand over this to Patric.
What I want to talk to tonight is probably tell a little bit more about the story of our first foray into IoT. So a little bit of background. As an organization, we focused a lot more on the build of custom software. So we build out a lot of things in terms of digital applications that would leverage a bunch of APIs, but we hadn't necessarily started to have a bit of a foray into IoT and how it could be integrated into those solutions. So what we're really good at, building out applications. We know a lot about large sets of data. We know a lot around integration. We know a lot about cloud platforms. And we would also know a lot about the connectivity of how they all fit together, but only from a software experience perspective. And so for us, what got us excited is effectively the merging of that whole physical and digital. So what IoT enables us to do is have something that's in the real world that can augment and extend something that we can build for someone in software. And so that's kind of the thing that got us really excited about why we were going to focus on IoT as kind of a capability. And I'll talk through our journey in terms of agriculture and what we've done, and probably most importantly, what we've learned. Because we've taken a bunch of core skill sets and thrown them at the problem. We've learned a lot about the hardware and network side of IoT, but even having this as a product that we've put out in a bunch of vineyards, we've learned a lot more around the commercialization or some of the challenges that we see when looking to roll out solutions that do merge that whole physical and digital. So if I go to the next slide, I'll kind of touch on a little bit in terms of the industry that we had a look at. So for those who are AU based, agriculture is a big part of what our GDP produces, about 2.5%, but growing rapidly, close to $100 billion business by 2030. And it's a large employer within Australia. And as people talk about food security, it's becoming a larger and larger consideration of something that will be important to us as a country and also the world more generally. And one of the things that have consistently come up in terms of trends is the scarcity of water and the impact that it has on the growing of agricultural products, the impact of invasive weeds and other things that inhibit the growth and the sustainability of agricultural pursuits. And lastly, there's a lot of things that are starting to come up around soil. So believe it or not, it's almost like the tip of the iceberg. So you can look at something aesthetically, but it's often under the ground what's going to have the largest impact in terms of what we produce and what we grow. So we thought it was also an industry that people could associate with. So everyone goes to the shops, everyone buys produce, but it's also one that people can then start to understand some of the differences from a yield, from a quality, and it's quite accessible to people as well. So we started to look around, well, what could we consider around applying IoT as a concept into agriculture? And one of the first things was starting to understand what some of the challenges and the limitations would be. And probably something that you may have touched on in your first meetup is there's certain constraints that don't exist now that used to exist in terms of the cost of IoT devices, the microcompute chips that are available, the cost of computing in terms of large amounts of data. So they're all things that have become enablers. However, there are still a bunch of constraints that exist in an agricultural context, especially of those that are in Australia. We're a huge country. We've got the tyranny of distance. Often you'll find that agricultural land is in the middle of nowhere, literally and figuratively. And so some of the things that we often run into, which, for example, may be less of a challenge in places like Singapore, is internet connectivity. So we've got the NBN, which we've rolled out across the country, which in some instances is fiber to the node or fiber to the curb, and others it's satellite technology. And there's still parts of Australia that don't actually have connectivity. Technology literacy, we're talking about farmers. Gut feel is typically the way that farmers work and how they've grown up. So them having knowledge of an IoT device, them having knowledge around how to interpret data is a big inhibitor for the uptake of what they do. Access to power. So again, similar to connectivity, we're talking about locations that can be far away from power sources. So things like importance of battery technologies and solar panels have become increasingly important in agriculture. The sheer number of devices that we might have in an agricultural context. Australia is known to do a lot of broadacre farming, where you could have hundreds of thousands of acres or hectares, whether it be managing cattle, whether it be growing tomatoes or other produce. So you've got a whole device management complexity, which then feeds into probably the one that's been the biggest learning when I talk through what we've done with VInOT in terms of agriculture for viticulture, is cost per unit. So farmers are especially sensitive around cost. If you look at it as an industry, your fixed costs remain pretty similar year in, year out, but your yields and the price based on market conditions can vary greatly. So in the agricultural industry, you'll have people comparing the cost of technology to the cost of fertilizer or the cost of making a fix to one of their tractors. So the whole technology literacy and cost per unit starts to become a really important consideration for people to be able to consider, what is the value that I'm going to get out of this solution? And do I believe that technology is going to make a change? Given a lot of farmers historically have been more gut feel, as I said before. And one of the other ones that I think is really complex, and today we won't talk about how we necessarily solve it, we'll talk about how some of the devices we've used consider it, is field services. So what happens when a device doesn't work? How do you actually set it up when you live in the middle of nowhere? So I've had a bit of time and consideration around an onboarding experience for an IoT device. And also, well, what happens when it stops working? So there's some of the things that really are the problem domains within the agriculture context. When we look at it, it's ripe for a bunch of different technologies, whether it be sensors in terms of observing in real time what's happening, actuators for things like irrigation or turning on implements and things that will support a farming enterprise. And then, obviously gateways and other things. And we'll talk a little bit about LoraWAN in this instance in terms of what we used. I won't talk too much about the types of sensors. I'll talk about that when we explore VInOT. The one thing I will talk about is the networking selection for agriculture is really complex and actually quite difficult. And we'll talk about it in some of our key learnings, but we ended up going down a pathway where we used LoraWAN as a technology. Idea behind that, you can be in a rural location and you can have 7 to 10, depends on the location, the undulation of the territory. You can have a base station in significant coverage to support what are typically broad acre farming enterprises. So it made a lot of sense to have a LoraWAN. However, if we had our way, everything would be 4G or 5G, because it takes away a whole heap of hops and complexity in terms of how we have to build our solution and the number of components we need to support. But one of the challenges, especially in Australia, we don't have ubiquitous coverage of 4G or 5G. We don't have ubiquitous coverage of technologies like Sigfox. So there's almost like a lowest common denominator that we've had to consider around what type of solution might be fit for purpose. And one that hopefully in the future, and we've seen recently, there's certain devices that will actually support 4G or LoraWAN. But it's definitely one of the key learnings that we've picked up as part of working through this. So what I'll do is kind of introduce VInOT as a product. So for those, I'm not sure how many people have got a keen interest in grapes. One of the benefits I've got is I make wine, grow grapes and things like that, which means I get to kind of push some of the things we do, as Tony will know, into some of the passions that I have. So I'll kind of touch on it where it's a bit different to other farming activities or exercises. When you're growing grapes, you could be paying $300 for a ton of fruit. In Australia, it's in places like the Riverland, where you might get 15 tons to the acre in terms of yield, or you could be paying $30,000 for a ton. So it is not a homogeneous crop like you might have with wheat and other things like that. There's a considerable premium that people are prepared to pay based on location, based on quality. That's effectively passed through directly to a consumer. So when you look at that from a cost perspective, if there's ways that you can incrementally increase quality or you can increase yield, there's a fundamental impact to the bottom line of people that are actually farming or growing these products. So we thought it's an area where it makes a lot of sense. In grape growing as well, there's a bunch of different variables. You can go from 1 year getting 5 tons to the acre to getting 0 the next. So these variables are often around things like disease control, timing of watering, because overwatering can actually impact quality in a negative way. So there was almost a bunch of areas that we believe if we get it right here, you can probably apply it almost to any agricultural pursuit, given the complexity of growing a crop you only get once a year, and that has a number of variables that go into making it. So in terms of the how we looked for this solution to help was really about providing real-time information around climate and other relevant sensor data, but also interrogating it against historical and projected values. And we'll talk about that when I talk through the demonstration. And then to start to move towards predictive insights as well around what have we learned. A really great example is if you're growing grapes throughout the growing season, there's a couple of things that can really impact the quality and yield of what you're going to produce. One's called Downy Mildew, the other's called powdery mildew. And that's often comes about when you've got high humidity or there's been a lot of rainfall, and then you've got temperature that's greater than 15 degrees, less than 35 degrees. There's a bunch of things you can do that preventatively, like spray copper and sulfur, which over a 14-day period should stop that from happening. However, if you don't do that, you can potentially lose your whole crop. So looking at things like, when did I last spray? Looking at things like, what is the projected forecast based on the Bureau of Meteorology in Australia, can start to give us insights and predictions on what should I do. So it's all about taking real-time data, augmenting it with other data sources that might be publicly available to us, as well as looking at historical data to help with decision making. And that's really where we start to see the value in terms of what we're doing as well. So I'll kind of just talk through, and this is just a conceptual view that you'll definitely be aware of, and it'll make a lot more sense when I step through the demo. So in this case, we're fundamentally focusing more on sensors at the moment. I'll talk through the labellium devices that we've used and a bit more of the technical implementation in a moment. And so a typical use case, so we're collecting data, we're ingesting that data. So we're ingesting raw data. So we've got historical data that in the future we can interrogate in different ways, shapes or form. We're storing that. And then we're effectively, this is where we're building an application that effectively uses our sensor or IoT data as a source, aggregates it with other information that we've got captured through a bunch of other APIs, and then helps us deliver an interpretation and react to it. So a pretty simple and pretty consistent use case that you would see across almost every IoT use case. The one thing we haven't necessarily built yet is the actuators on the other side of it. So in our first implementation where we built our own device from a chip up, we actually had an actuator that started irrigation. But our levels of confidence with the homemade chip that I think Tony was involved with, having mains pressure water, was probably not as high as it could be. So that's kind of an example that we'll continue to move through. So I just want to talk briefly about the technical implementation, and you will notice, so AWS is at the core. There is a bit of Google in there purely around the simplicity of us building out some of the UI implementation, but AWS core was kind of the key component we used. So I'll kind of start from the bottom. Firstly, I said at the start, we're not necessarily experts in building hardware. And if I look at one of our learnings longer term, and I'll talk about costs later, vertical integration of the hardware device is probably into the software solution is probably the only way we can get something to a cost per unit that will be viable in an agricultural context. But what we wanted to prove was build an MVP around the software concept and the value of our solution, which is what we've done. So in this instance, we used Labellium's Agri Pro sensor device station. Effectively, it's got an Arduino chip sitting in it, and it's got a bunch of pre-configured sensor devices. So, this was fit for purpose around making sure the idea and concept work, and that we could get a level of accuracy from the IoT device. So the types of information we've been capturing in terms of weather, rainfall, wind speed, wind direction. We capture the soil moisture at 2 different levels. We'd also capture basic temperature, humidity, and pressure, as well as simulating what the leaf leaf moisture looks like. And effectively, these are all, I suppose, the key indicators that help us make decisioning around what to do at a certain point in time. Things like the leaf moisture and the soil moisture dictate when we should water. The weather station, temperature, humidity, wind speed, etc., helps to dictate what we might need to do from a preventative management perspective. When we move up further, as I said before, we chose LoraWAN because of I suppose, the ability for it to work in most instances. However, we probably would have preferred to have 4G, because as you'd probably all be aware, when you've got LoRa, you then need a LoRa gateway, which is another moving part to have within a vineyard. We've also then got an intermediary in terms of the Things network, which was fit for purpose again in our case. There's an integration between the Things network and AWS IoT Core, which effectively publishes the events that come from the LoRa gateway into Amazon. So we use Amazon AWS IoT Core for device management and the synchronization between LoRa, our physical device, our LoRa gateway component, and Amazon. And then we effectively leveraged the AWS Firehose into S3 for raw data. And then we built a telemetry ingester that would then push the data into a time series database. And we'll talk a little bit later, the world's moved a bit. One of the pains in the backsides was having to build and run our own time series database, but with some of the Amazon products now, there's ways that we wouldn't necessarily have to do that. Sitting on top of that, we obviously had a bunch of APIs that would not only just show the telemetry data, which is what we're getting from our vineyard, but we built a bunch of other APIs that would help us map a vineyard location. It would help us map a block within it. It would help us capture events and observations that we didn't capture through our sensors. And so this was how we were then able to build more of an experience on top of what was a bunch of IoT data that gave me temperature, humidity, pressure, leaf wetness, and things like that. And effectively expose this via a Flutter application and a React application via mobile and web. And probably the other thing as well is this, when I spoke at the start, once we manage to get our data into the Amazon ecosystem, it's like building any other application. The principle is we've treating IoT data as a dumb API. And for those who in Australia use the bomb, it's kind of the best example of an IoT API that's been available for a long time and everyone else has been playing catch up. So that was kind of one of our key moments around IoT data will be part of our solution. It's not the only thing, but it does help us, I suppose, fill that void between the physical and the digital. So what I'll do now is I'll kind of do a quick demonstration of VInOT so we can actually see that's what the device itself looks like. So that's sitting out for those who are following at home in the Macedon Ranges in Victoria. Believe it or not, it's the coolest wine growing region in mainland Australia. And what we've actually done is we've got 2 sensor device stations within probably about a couple of 100 meters of one another. It's been fascinating even seeing some of the slight variations between 2 locations. So if you bear with me for a moment, I'll just start that up. I'll see if I can share a different screen. So let me stop sharing there. While I do that, are there any questions before I do a quick demo? I'm mindful of the time as well. Let me just...
So you had to roll out some of your own LoRa gateway nodes around the place to be able to get this happening also? Yeah,
we did. So we effectively, I know, Tony, while I set that up, if you want to touch on it.
Yeah, we did. So we had to set the nodes up so that we can ingest the data and then stream that into the AWS IoT Core itself. So, and as we all know, managing your own devices can also create those little headaches as well. So, yeah, any other questions from the group?
By the way, how many minutes does it take for the IoT device to send the data to the Things network and to AWS IoT Core? And how frequently is the data sent?
Every 5 minutes we've got as the refresh rate.
Oh, 5 minutes.
Yeah. So and part of the logic behind that was if we look at weather and temperature data, 5 minutes is an appropriate timeline in which it makes sense. So as a second by second, even though we can't actually do that with LoRa, even though we're running our own LoRa gateway, so it shouldn't matter. It was something that 5 minutes seemed to be an appropriate time point. Where there was no value having finer grained data, given then the additional cost we'd have around data storage. So 5 minutes, we probably could do it closer to 10 minutes, but 5 minutes seemed like an appropriate timeline.
So if there's a network issue, so you still have to use another data storage for that, am I right?
Yeah, so if there was a networking issue and there was no, I suppose, persistence of a message, so and you can actually see it here, and some of the learnings as well, that if the gateway was down, we didn't have an edge cache, for example, to capture that data and then push it through at another point. So you can see if you can see in my mouse, there's still point times, you know, for a 5 minute period, for example, where the message actually hasn't been received by the gateway. But as you can see, it has minimal impact when we look at a data set of temperature, as opposed to if it was something that needed kind of real time data.
Oh, I see. Thank you so much.
Yep, no worries. So I'll kind of just talk through it. And there's one component, we actually broke it the other day, which I'll talk through. Unfortunately, I didn't tell Tony about it. What we've got is we've actually got a multi-tenanted solution as well. And so one of the things we were looking to solve for is how could we roll this out as more of a SaaS platform. So effectively behind the scenes, which we won't demo today, we've got what is quite a complex admin process to be able to associate a physical device, which those who are aware of the Labellium devices has a unique identifier, with a physical space that may be then associated. So a vineyard that might then have a vineyard block. So there's actually a whole hierarchy of complexity that comes into play when you're trying to associate something that you'll send out to a vineyard owner who then needs to deploy that themselves. And so that was an interesting learning around that whole onboarding experience and how would you get someone very quickly up to speed and able to actually use this. So I'll kind of talk through. So I've got a basic dashboard that talks through that basically talks through the temperature and real-time data around wind, rain, and humidity. We've got data that we're pulling from the Bureau of Meteorology. A component that we broke was is the one that's doing some smarts around providing frost warnings. Was also one that would tell us about water stress events. So it would look at a threshold, and if there was no rainfall events predicted in the coming days, and our soil moisture got below a certain level, it'd send a push notification alert. And it also talked about a couple of other considerations around sensor status. So if there was outages for the sensor status. So what I want to kind of touch on is we can start to see different data across different time periods. So I can see the data in the vineyard for the last 24 hours. I can see it for a 7-day period, or I can start to see that trend over the last month. And I can see that across a bunch of those different variables. So this in its own right, coupled with both the future predictions and historical data, can provide us some value around what to do next. But where it starts to get really interesting is when you take observations as well. So a sensor device can't tell me the quality of what I've produced. A sensor device can't tell me that I just pruned a vineyard, but I can have other events that I can correlate. So what we've actually built is the ability for us to add different events. So, over the growing season, you might add nutrient to the vineyard. You might water it at a different point. You might spray it at different points. There's different points where the vines will go from being dormant to bud burst, to flowering, to what's called fruit set, to veraison, which is when they rapidly accumulate sugar and they're getting ready to be picked. And so there's all these different things that will be impacted based on the data that we're seeing from an observational weather perspective. So where it starts to get interesting, if I look at bud bursts, for example, and let's say the date of bud bursts, and I'll just put it as today, just to make it so we can start to see, was the 27th. I save that. I've now started to capture observational data, which I can see here. Bud burst was on this date, that I can start to correlate with the other data that I've captured. So that's kind of the next step in terms of what we're starting to do. So I've got the real-time data. We've got some of the forecast data, where we can start to make some basic ML predictions. But where we get going to next from a product perspective is how do we actually take this and have these other observations that only a human can see and associate them. And that's, as we're building this data set over time, that's where it can start to get pretty exciting. I'll quickly jump back because I'm mindful that I'm probably running a bit over time. So jump in and let me know if you want me to kind of stop there. But if not, I can jump in and just finish the last couple of things around the key learnings.
Yeah, you can go ahead. Yeah.
Yep, awesome. So let me just do another share. Let me go back into that guy. As you can tell, I quite enjoy talking about IoT, so I could be here all night, which I'll try not to do. And so I'll just go through a couple of the key lessons that we've learned. So one thing that I will call out, I'm not sure if everyone's had this experience, is the quality of the sensors vary. So even though these devices that we're talking about, each one of those labelling devices probably costs close to probably almost $2,000 when you consider all of the sensors that are attached to them in the device itself. And we've actually been quite disappointed by the weather component. So the one that captures rainfall, wind speed and wind direction. There is a next level up, but it was close to $3,000. So all of a sudden, when you're looking at that component, is there value if we're looking at rolling out 10 of these within a small vineyard? To that point, the price per unit we found in this case, if we went down the same pathway and scaled what we've done with the labeling devices, we don't think it would scale from a price point perspective. So our next step would be starting to look into, could we manufacture or have a device manufactured for us that solves just specific problems, and we could lower that unit price. We kind of touched on it, where leveraging LoraWAN adds additional hardware, network and server components that really impact the provisioning process and also service availability. It's another moving part that's probably in a physical location you're not at. And so the more parts we have, hence why we're talking about 4G and leveraging as few components as possible, pushing data straight into IoT core, not having an intermediary would make our life a lot easier. And we think in the future that will make more sense, but we do have tyranny of distance here in Australia. Also things like time series databases. So at the point of building the product, things like AWS time stream wasn't available and it's still not available in region. So there were still some things we had to do based on the type of data, even within Amazon. I think those things are improving at the moment. And the last thing, as I said, is if you're building an IoT product, consider the onboarding flow. So how does someone take your physical device that goes out to them? How do they start using it? What happens if it fails? Who's going to fix it? And even starting to look at things like kind of models in terms of subscription models. So, we've tried a few subscription models around vineyards to amortize the cost of what is an expensive hardware outlay. And probably the last couple of things as well. So we're really thinking around IoT as another data source. So it is a huge part of the solution we've built, and we couldn't build the product without it. But there's other overlays that we think add as much, if not more value to pull in a great experience for a grape grower. And then lastly, I think on the cost front, it's a great time when we consider IoT, because from a platform perspective, the problems are pretty much solved now, right? Once you get data into Amazon, happy days. What's happening now in terms of edge computing? Once we start to get that cost down, the world's our oyster. So I think we're on the cusp. So there's a lot of things we can do now at lower cost. It's just the consideration around that true commercialization of getting it in someone's hand and what happens when it breaks or when it doesn't. So that's kind of a bit of a foray into VInOT and what we've built. So it's out at 3 different vineyards now. Next step is to confirm what we want to do next in terms of some of the ML data, and whether or not we decide to take it further around getting hardware built specifically for us to lower that unit cost. So I'll stop there. Thank you for letting me take up a little bit more time, but happy for any questions or happy to just jump on to the other presenters.
Okay, so we'll reserve the questions at the end. So let me thank you, Patrick. It is quite impressive. You are touching down to the most important part, like that's the agriculture. Everybody's talking about food sustainability. And so going into agriculture is not that easy, and it's to making a monetized model. It's really challenging. Okay.
Yeah, well and truly, like this model won't make money. it best you can cover costs. And so until that scale proposition goes down, it will be hard.
So I'll talk about the OPC-UA and Greengrass and the Sitewise. After that, we'll just discuss about it. So a little bit about me. I've been working in technology industry for 13 years. And before starting this Delighteck as a consulting firm, I worked for these companies like NVIDIA, Samsung, and different domains. We a little bit contributed to Linux kernel as well. So as a consulting firm, we are focused on mostly AWS IoT, firmware development, and the serverless software architecture. We worked with health tech, aerospace, marine, and Industry 4.0 as well. So Greengrass, if anybody is new to Greengrass, I would encourage you to watch the last meetup video, which is available on YouTube. And in short, it is pure software. You need to bring your own hardware. You can build all whatever you want. So I believe this green grass it's like a green field. Whatever you want to do, you can do, like play football, cricket, whatever you want. So similarly, you can build different use cases and solve your industry problems. So right from collecting data, running inferences, and taking decisions on edge is possible on Greengrass. So when it comes to the manufacturing facilities, or let's say industrial automation, there are actually, let me go back to this one. So there are, so you might be knowing that there were so many ports initially to your desktop computers, and now we have only USB-C in most of the newer laptops. So this is how we have solved all these problems with USB-C. And definitely there is a complexity which is taken care by USB stack and the devices on the other side of the USB, like we can say client. So same way, we have so many devices like CAN bus, Profibus, Ethernet, EtherCAT, different sensors, actuators, Profinet, Modbus over TCP, or Modbus over RS485, and then it becomes very difficult to make it available on the cloud, because all those the protocols were not designed as secure protocols. So once we add this OPC-UA, that's a open platform communication, they unify all these protocols for machine to machine communication. So it's better to have the standardized structure, and this is developed by OPC Foundation. Just in case you want to develop OPC server, there is a little bit cost involved, more than your development cost. And if you are like OPC client, then you can do it without additional overheads. So with OPC, it can store time series data. It can store alarms and events. It is a client server architecture. And where does the Greengrass sit with this, right? So from all these protocol sensors, PLCs can be connected to this OPC-UA server, or this OPC-UA server can be a part of those devices. And we get these data on these OPC clients and can be forwarded to wherever we want, like a cloud. So here comes the Greengrass. It can talk to OPC server, get all this data and forward, or you can, so there are advantages of using Greengrass, like we can run Lambda functions right onto the Greengrass, and we can develop the custom components which will communicate to OPC-UA, and then we can send the time series data to maybe Kinesis, AWS IoT, and you have rules engine, and you have literally unlimited storage with S3. So you can do data analysis, and doing this custom component implementation, bringing everything to the cloud, it takes a lot of development efforts. So here comes the fully managed service by AWS. It can collect, store, organize, and you can monitor the industrial equipment data at scale. IoT Sitewise also sits on top of Greengrass. We can call it as it is a connector or adapter. And so any kind of equipments like PLCs, sensors, industrial like forklifts, everything can be which is compatible with OPC-UA server. I mean, most of the industrial automation manufacturing facilities, which are a little bit newer, has a OPC-UA server running. But most of the equipments are connected to OPC-UA server. And here comes the advantage to bring that to cloud with this Sitewise with time series data. You can do, I mean, within few days, you can roll out a POC or maybe a production ready software. With, I mean, on cloud, you can run inferences, ML models and all that. So this is a simple Sitewise demo, which, okay, in these are the turbines, wind turbines. On those turbines, there are multiple sensors, and supposedly the Greengrass and IoT Sitewise connectors are installed on these turbines. That is how it will communicate with the AWS IoT core and the rest of the, like it can go to Lambda, store data to S3 data lake, and we can route it to TimeStream or Kinesis Firehouse. It looks like this. So let me quickly show you the demo out of for this to the Sitewise here. So this is how it looks. I have to. So these are the models. WinForm models, and we can see all the configuration here. So this is a ready-made demo given by AWS. You can just click and within few minutes you'll be able to run this, but make sure you switch it off after your trials because it's gonna cost more. These are the assets you can add in here. So different turbines, you have asset we have added here. So we can ingest the data from these devices, then we can build the models on top of it. So we have to categorize those data into different, so that we can put it into a logical format. And we can also monitor with this, like something like this. So this is a, you can quickly create a protocol, portal like this is how the portal looks like. This is a dashboard. You can, so you can see here all these turbines and all we are getting the data from, and you can build quick dashboard from like this. Here you can add the assets from here. Let's say we want to see average power generated by these turbines, rotations per minute. Then we can do wind speed. And let's say top. Okay, so all this data is coming live, and you can see, you can easily see it here. Last 1 hour data, maybe last 5 minutes data. So from all of this data is time series data coming from IoT Sitewise. And you can easily do whatever you want on the cloud side to make the inferences to come up with the decision making. Eventually, if you are able to build models out of this, those can also be deployed on Greengrass. So Greengrass is, I mean, those are running on few gigahertz devices, will not, so maybe 2 or 3 gigahertz. So may not be suitable with limited memory for training the models, but you can train the models on cloud and deploy it on the edge with on the Greengrass. Okay, So this is, so you can easily add multiple users here. It is using your IAM user as a credential. So it's very easy to build like this. So if you want to use something for the industrial facilities, I would recommend to look into AWS Sitewise for quick POCs. So next one, we can just go for the green grass and OPC-UA demo. So in short, so we have this OPC-UA process, OPC-UA simulator running here, wherein we can see all these sensors, data counters, all this data is getting changed here. So what we have is a custom built component for Raspberry Pi. And when it comes to the debugging, the greening grass, if something goes wrong, it becomes very, very difficult to see, because what you can only do is the logs. You can log in and check the logs. So it can, this visual representation can help you to see whether there is any problem in different components. So most probably the custom components might have the problems, as AWS is taking care of their own components. The nucleus and CLI, those are quite stable as far as I know. So let's say what we want to do here is this is running as a server. We go here, and so this is a custom component we have built. You can also see this custom component on the green grass. Yeah, IoT core, and then you can see your core devices here. Sorry, I am in a wrong region right now. Yeah, so this is the device. It is saying it's unhealthy for some reasons. So right now it is working fine. So now you can see these components. So this is the component which we have. And what we want to connect to is the local server. We can pass in this OPC-UA server URL directly from here to those greengrass devices. In case you want to have a different servers to connect, we can have an array, and you can put in some logic to connect to. And this is how you can start deployments. You can create, so these are the private components which we built. There are a lot of public components available. So last meetup, we discussed about the object detection for using Raspberry Pi and these ML models. And all those object detections were happening at the edge, and it was only sending the JSON data to the cloud. Okay, so now let's say now this is the component which we have. It has let's say it has this kind of so it has artifacts and recipes. So this is the current version of this component. So you can see this is the program it will run. So we can simply try to run this program as well. Okay, so now this is connected to this server, and this is printing those values. We can send all these values to AWS IoT and do the similar things what the IoT Sitewise use case has been doing. So this is we can say, in case IoT Sitewise is not suitable, or it there is no customization available for your specific use case, so you can build the custom components on top of greengrass. Okay, so that's the quick information I wanted to share. Any questions?
I have one question regarding the
Yes.
OPC-UA for Greengrass 2.0.
Yeah.
But can you run it as a lambda, as a long living lambda, as like in the Greengrass 1.0? Because now we have custom applications, right?
Right.
And where you do you define this as a long living lambda, and it runs forever like in Edge 1.0?
Right now, no, because the OPC-UA adapter which is available is based on Node.js, and Node.js is not yet supported in Greengrass 2.0. And that is what we are doing right now, building Python, Python adapter similar to Node.js.
Okay. Okay.
So if you want to go ahead with the different use cases, I would recommend go through these links. And for OPC adapter, this is the code what we have here. This is definitely, as we said just now, it is based on Node.js. Hopefully we'll sooner have a support for Node.js.
In Python, because I'm reading what you're saying, we use Node.js OPC-UA in Greengrass 1, and the Python. The reason that we are not using Python, I think something that people should know is be careful using this one, okay? Because this is on the development perspective, it's only one maintainer on the Python version of OPC-UA, and it's marked as beta. So to production use, I think probably people are better to use AWS IoT Sitewise Edge, which already has OPC-UA built in.
That's correct.
Yeah, or Java version, which is supported. Yeah.
On Sitewise workshop, yeah, this is the link. We can you can easily go to your AWS console, go Sitewise, and you can quickly launch the demo which we just saw as this one. So going ahead, we would encourage more people to contribute and speak to the monthly events. So these are some of the topics which are people are interested to know about. That's the IoT core for LoraWAN, and Greengrass core with custom components and model deployments for custom use cases. So if you would like to listen to a few topics, suppose you have a specific use case and you want to use some of the services from related to AWS IoT, we can plan some talk on this with respective experts. We had a few questions for Patrick, I believe. So
question for the DigIO LoRa people.
Yeah.
It's more on deployment strategy. How do you guys on a scale of things? How are you guys deploying? Because for example, as we use LoRa, and it's currently deploying the software to LoRa is being a very hassle thing to us to scale. How are you guys doing it?
Are you talking about doing OTA updates to the IoT devices, or actually just deploying the LoRa gateway component?
So let's say that there is a new version of your gateway, right?
Yeah.
Or so because how do you deploy that new version, for example?
Yeah, and that's something we haven't faced into as part of this. We've been fortunate enough that because we've ran field trials, we've actually deployed the LoRa gateway component and haven't needed to have updates to the hardware. And I suppose it probably feeds into that other consideration where what we found is typically needing to have devices that allow OTA updates. And there's one thing which is the LoRa component, but the bigger one we've had is making any changes to the IoT devices themselves. So if you look at the example we've got the LoRa gateway component, but then obviously we've got the sensor station. And so then if we want to make any changes to the sensor station, it actually needs to be a USB into a laptop to actually update any of the firmware. Whereas the reason why we spoke a bit about ideally, if Australia wasn't such a big place, the ability to do OTA updates via 4G is something we could actually do and take the server component out of it, because we haven't faced into the LoRa gateway updates, but the issue that we'd have is we've got people out there that have no idea. Like if something goes wrong, you're saying they'll go look at their internet router, not even a LoRa server, or they'll switch on or off the gateway. So we haven't faced that, Mara, but I could only imagine how difficult. What have you found in terms of what you've had to do for the gateway components?
We have it for us. It could be a talk just for regarding how we use LoRa, but what we have our LoRa is sending data to a DCS. So then it's in a total different network, and we do upgrades over the air to it through a proxy, yada yada. So I will go very technical on this one, but yeah, on the software side, but of course this causes bottlenecks on
and is it in terms of, because one of the more interesting things, well, and it's kind of takes a little bit away from kind of the Amazon ecosystem, is I suppose that networking technology, because that's the one that we spend a lot of time thinking about and has such an impact to how we build the solution. So I'm not sure if anyone else is finding either use cases where they can move to 4G or low latency 5G, or we've got Sigfox here that is making some progress, but doesn't, given the size of Australia across the eastern seaboard, it's struggled to get kind of that mainstream adoption. So I don't know if other people are finding that or think that networking technology will make life a bit easier to get it into the cloud platform, or if it's just us.
I don't have any more questions from my side. Thank you.
Hey Patrick, so you're actually also making and growing grapes and all of that.
Yep.
Is that right?
Yeah, correct.
So why did you decide to focus on that particular area rather than, say, the fermentation or the storage aspect of what you could have done with it?
Yeah, it's a good question, because I actually did some models around how we could actually consider a IoT-enabled winery. And some of the biggest considerations there were the practicality of, especially when you look at in a winery, you've got individual barrels. So rather than, let's say, if you're in a brewery or something like that, you've got one tank. You've got a lot more mobile fixtures within a winery. So being able to actually have physical devices in a barrel, for example, doesn't quite make sense. How are you going to power them when you've got 100 different barrels? So the reason for that, so that was kind of the primary reason. Also, probably the point I said before, it's really in the grape growing that wine's made. So I could talk for hours about wine, but effectively the cast is almost set when you pick the fruit. And so it's why you might find fruit from a vineyard that maybe was $300 a ton compared to a vineyard that was $10,000 a ton. The raw material actually makes a marked impact. So kind of looking at it at the start of the process, there's probably more incremental gain in the quality of the fruit than what IoT may enable in the winemaking process. So I make wine as well. And there's certain things around temperature and things like that can impact. But compared to other products in food science, and even if you compare it to beverages like beer, temperature is not quite as important. Where certain things you might need to keep it constant at 13.3 degrees without moving, whereas you've got a little bit more wriggle room with wine. So that's kind of why. So two things: bigger impact in the vineyard, and just the one-to-many relationship of having multiple barrels and fermentation vessels in a winery, and just the mechanics of having those physical devices within it.
Sure. Just one other quick question. So focusing on that part of your process, and something that's actually very, very active as of January 2020, have you considered other sort of things such as particulate collectors? You got obviously smoke taint damage was a big problem for you guys a year and a half ago.
There's kind of two other things that we'd look to include, because step one was making sure that it was a viable product, and from a would people pay for it, etc., and can we get the insights, which is where we're at now. Kind of the logical next couple of things that we'd look at particular sense around smoke, well and truly. For those who don't know, smoke can have a huge impact on grapes, and you could pick the fruit and then find out after spending hundreds of thousands of dollars making a wine that the impact of smoke makes it undrinkable over time. So that's definitely one area, and there's a lot of research going on that at the moment. And the other one, which will sound odd, is actually using computer vision. And I'm from an edge IoT perspective, and things like wild deer in the Yarra Valley in Victoria have a huge impact on grapes to around the time they're being picked. If you see certain vineyards are planted on their own roots, which if you've got someone who's walked around a vineyard that's infected with a thing called phylloxera, over years your entire vineyard could die. So there's some other really good use cases that will bring in other things like computer vision. And there's other sensors around kind of infrared radiation and things like that that can also be useful. So yeah, there's a few other things that we'd like to bring in, but at the moment we're limited by the sensor stations that we chose to focus on. Good question.
Okay, so how did you end up choosing the LoraWAN opposed to like Sigfox and VIOT?
It's connectivity above anything. So a lot of vineyard locations are quite undulating, which means cell phone coverage can be hit and miss. And in terms of Sigfox, when we looked at the rollout, and we started this process probably 18 months to 2 years ago now, they've almost focused in Australia, from my understanding, almost like the telco networks. So they're going to be around more major centres or major regional centres, whereas Laura was the only one that when we're rolling this out in lots of locations, we're 99% sure it'll cover most scenarios. I would love to use 4G because we wouldn't have had to worry about a LoRa server. We wouldn't have to worry about all these other components. We've got a solar panel on an IoT device and the data just goes. So that would be our preference. But if we did that, we'd be limiting, and sometimes we wouldn't actually know whether or not it would work or not, because the location that someone will put it within their vineyard might actually not have cell phone coverage, but the hill does. So a couple hundred meters away. So it's more around looking at the lowest common denominator of who would use it.
And how about the suppose the LoraWAN, the server you put in there, it's supposed to have a network, like good network to send it to cloud, right?
Yeah, and so that was where the assumption we made, which is held true, that it's somewhere in a 7-kilometer radius from where the sensor device is, there should be some kind of internet connectivity. So that was a fail-safe. If there is no internet at all, then nothing will work. But it was a better bet to say, back at the house, maybe they might have internet, or they might have a 4G hotspot or 4G location somewhere. And so that was the idea behind it. I think we can sign up for Skynet. What's Elon Musk's internet at the moment, and so that I think would kind of change the game as well. Skylink, there we go.
Sorry.
Yeah, we have any more questions?
I think that's about it, Vishnu.
Yeah. Okay, I think if we don't have any more questions, we can just sign off. And please remember to RSVP for the next event. And
Awesome. Nice to meet everyone.
yeah, thank you. Thank you so much, Patrick. Yeah.
Thank you so much.
Bye-bye.
Bye for now.
Bye all.
Thank you.